few different things in the 3 examples that I have for you. Example 1 is an equation that's already in standard form. So to graph a hyperbola, just like all of the other conic sections, your equation should be in standard form first. So the equation is already in standard form. Question 2 actually isn't graphing. It's just using that constant difference that was part of the definition of a hyperbola to find the equation of a hyperbola. And then the 3rd question is also graphing, except you have to get the equation into standard form first, which is very similar to how you got ellipses into standard form. So as we look at example 1, there are many parts to these graphs. You just want to make sure that you understand how to get the graph of a hyperbola. So first of all, looking at example 1, just like we did for parabolas and for ellipses, you need to identify the orientation of the graph. So is it horizontal or is it vertical? So looking at this equation, what do we think? Is it horizontal or is it vertical? Horizontal, and why?
Because the x is first and then into the y, and if it was vertical, you would have the y first and then the x.
Yes, so hyperbolas, remember, there's one term that's being subtracted, so the order that the terms are in does matter. If the y is being subtracted, then it's the horizontal. The y is the negative term. So this is horizontal. Okay, and then just like we did with ellipses, I would identify what is h, what is k, what is a, what is b, so that we can use our formulas to find the given or the information that I have listed there for you. So what is h?
3.
H is 3, k.
Minus 5.
And then what is a? A is 2. So the a squared is under the x in the horizontal hyperbola formula. So square root of 4 is 2, meaning b is going to be the square root of 9. So b is 3. And again, for hyperbolas, a does not have to be bigger than b. That was only for ellipses. So then center is hk. So that is 3, negative 5. And I'll plot that right away. And then we'll find our vertices and our co-vertices. And again, different ways you could find these. You could actually use the formulas that are on your sheet, or also remember, so if it's horizontal, your vertices are going to be to the left and to the right of your center, and it's a distance of a. So you could go 2 to the left, 2 to the right to plot your vertices, and then just make sure you're writing down the ordered pairs. However you do it is fine with me, as long as you have them written correctly and it's graphed correctly. So for vertices, I know I'll write the formulas down here underneath. Let's see, make sure I'm looking at the right thing. The left vertex has coordinates h minus a, k, and the right one is h plus a, k. So h minus a would be 3 minus 2. So it'd be 1, negative 5 would be the leftmost vertex. And then h plus a, 3 plus 2 is 5. So 5, negative 5 is going to be the rightmost vertex. And some of you, I know on your quiz you were labeling, like putting V's next to the vertices and things like that. That's fine. If you label things on your own graph when you're graphing it so you remember which is which, that's fine with me. Co-vertices, again, use the formulas, or they are up and down from the center in a horizontal hyperbola, and it's up and down a distance of b, so you could go up 3, down 3 to plot your points, or use your formulas to get your points. I'll write the formulas down. So the top co-vertex, it has coordinates h and then k plus b. And the bottom co-vertex is h and then k minus b. So let's see, h is 3, k plus b, negative 5 plus 3 is negative 2. So 3, negative 2 is the top covertex. And then 3k minus b, negative 5 minus 3 is negative 8. So 3, negative 8 is the bottom covertex. And be double checking when you're doing this as well. Look at your graphic organizer. Does it seem right? If your ellipse is horizontal, or your hyperbola is horizontal, sorry, are your vertices to the left and to the right of the center? Are your covertices up and down from the center? Are they all in line with your center? That's an important thing to note too. Okay, before we find the foci, we're actually going to graph this hyperbola. So once you have your vertices and your covertices plotted on your graphic organizer, you see that rectangle or that box, and make sure it's dashed. The box is formed by your vertices and your covertices. So you want to dash in a rectangle or a box that includes those 4 points or has those 4 points, 1 point kind of in the middle of each of the 4 sides. So the box, I guess, has a length of your conjugate axis and then a width of your transverse axis. And it's dashed because we're using it to help us graph the hyperbola, but it's not actually part of the graph. Once you have the box dashed in, then you want to draw in your asymptotes, those lines that your hyperbola will not touch or cross, and those, again, should be dashed in. So the asymptotes, remember, go through your center, but also notice we don't have to use the equation to come up with the equation and then graph using slope-intercept form. We could do that, but the asymptotes go through the corners of your box. So if you make the box, you can draw in the 2 lines that go through your center and the corners of that rectangle. And again, they should be dashed. Do go all the way through because we're using the asymptotes then to draw in the hyperbola. And then once you have the asymptotes drawn in, here's where you do need to pay attention where you put the vertices, where you put the covertices, so you're drawing it correctly. So remember, to the left and to the right of your center, those are your vertices. It should be opening left and opening right. You want to draw in your 2 curves and make sure that they do actually go through your vertices. So if you want to watch me draw it first before you start drawing it on your own, you're going to be going through your vertex for each half. And so if I draw this rightmost curve, I'm going to draw it. The asymptotes kind of show you how wide the opening is. So you kind of go towards an asymptote and you just follow that asymptote. You don't touch it, you don't cross it. And you do that in each direction. So that would be my rightmost curve, and then I would do the same thing for the leftmost curve. It just follows that line, that asymptote that you drew in. And so those should be solid curves that you're drawing in. That is the hyperbola. All the dashed things we drew in could be taken out. That's just there to help us get the shape of the hyperbola. After we get the last example into standard form, I'll have you graph it on your own. So if you have questions on the graphing part, definitely let me know. You'll have probably some time to practice in here too. Okay, and then after that, I do want you to find the foci and include the foci on your graph. So in order to find the foci, we need to first find C. And remember, for a hyperbola, C squared is equal to A squared plus B squared. So A squared is 4 plus B squared is 9. Meaning C squared is equal to 4 plus 9, which is 13. And then I do actually want to get a decimal approximation for C. because I'm going to have to use it to graph. So C would be approximately 3.6 square root of 13. And so I know the foci are also going to be to the left and to the right of my center. So I could go left and right a distance of 3.6 to plot them, or use your formulas to get the points and then plot them. Either way is fine. The leftmost focus is H minus C K, and the rightmost is H plus C K. And make sure, too, when you're plotting them that they appear to be in the correct spot. They should be kind of inside of those curves, so to the left and to the right of your vertices. So H minus C would be 3 minus 3.6, so negative 0.6, and then K is negative 5. So that does appear correct because it's inside of that left opening half of the hyperbola. And then H plus C, 3 plus 3.6, would be 6.6, negative 5. And that does appear correct as well, that it's inside of that right opening half. And that is the graph of a hyperbola. Any questions on example 1? Okay. So for example 2, like I said, this example is writing the equation of a hyperbola a little different than the ones you had yesterday, though. It's using that part of the definition of a hyperbola with the constant difference. So there's some information above that is helpful. So it says, in the equation for any hyperbola, the value of 2a represents the constant difference. 2a represents the constant difference. And this is the absolute value of the difference between the distances from any point on the hyperbola to the foci of the hyperbola. So it gives a little example diagram here to say this is your point on your hyperbola. It could be anywhere on either curve. So the distance from that point to one foci, they're calling x. The distance to the other focus, they're calling y. And so the absolute value of the difference between those distances would be equal to 2a, is what this is saying. So that constant difference can allow you to find the a value when you're writing equations of hyperbolas. So it says here, any point on the hyperbola that's given in the right here will have the same constant difference. So this is saying the absolute value of y minus x is equal to 2a. Now you could also, the reason they're taking the absolute value is if you look at this diagram, y appears longer than x, so y minus x is going to be positive already. You could also do x minus y, and that's why they have the absolute value, because a smaller number minus a bigger number will be negative, but we know that a distance should be positive, so that's why they're including the absolute value. So we're going to use this in example 2 to write the equation of the hyperbola that's described. So it says 2 receiving stations that are 150 miles apart receive a signal from a downed airplane. They determine that the airplane is 80 miles farther from station A than from station B. Determine the equation of the hyperbola centered at the origin on which the plane is located. So I don't really need to draw a grid here. I guess I could, though it's giving us the center is the origin. And there's really 2 ways you could draw the hyperbola. It's not specifying the hyperbola has to be a horizontal hyperbola or a vertical. So really there's 2 answers with horizontal and vertical. So if I kind of go back here, it says 2 receiving stations are 150 miles apart. And and they receive a signal from the downed airplane. So we're going to be using this sort of diagram. We're assuming the downed airplane, it does say this here, that the plane is located on the hyperbola. We're finding the equation of the hyperbola that the plane is on. So I'm going to use a horizontal hyperbola. But like I said, you could use a vertical. All that's going to be different is your terms would be switched around, but that equation would also work. Your a squared and your b squared are still going to be the same values. So the plane is somewhere on here. I'm going to purposely draw it in a different spot so the diagram doesn't look exactly like this. So let's say the plane is here. Somewhere on the hyperbola. So the two receiving stations they're referring to would be the foci of that hyperbola. And they're referencing station A and station B. It does say that the airplane is 80 miles farther from station A than from station B. So if I wanted to make this diagram more accurate, I would call the left focus station B and the right focus station A. It's farther away from station A. But I know that these two stations are 150 miles apart. I'm going to kind of make that note here. This distance is 150. So I have everything labeled that I'm given. I have to find the equation of this hyperbola. Okay, so if I'm using a horizontal hyperbola, I'm just going to write down the standard form for a horizontal hyperbola. So x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. I am given the center. It says it's centered at the origin. So therefore I know h and k are both 0 since the center is 0, 0. What I need to find then is I need to know A and I need to know B. Okay, so we're going to use the constant difference that was talked about above to find A. So I have a distance where my plane is. I have a distance to station B, and I have a distance to station A. So the distance to each of the foci. So let's say I call the shorter distance x and the longer distance y. I know then that the formula that was given up above, the absolute value of the difference of those distances, so the absolute value of y minus x is going to equal 2 times a. And I actually know what to set this equal to because it says that they determined the airplane is 80 miles farther from station A than from station B. So what that means is if I take the distance to station A and I subtract the distance to station B, that difference is 80 because station A is 80 miles farther. So the problem gives me that the absolute value of y minus x is 80. And therefore I know 2 times a is equal to 80. I can divide by 2, and I have my a value is 40. And then what we have left is to find b. We are not given the covertices. Covertices are usually what we use to find b. We are given some information about the foci, though, that they're 150 miles apart. Anybody know what we can gather from that in order to help us find b? $150 wouldn't be c squared, but we can use it to help find c. So we can find c. 150 is not c squared, but that's close to how we could find c. What is c? What does c represent on the graph? Because remember, a, b, and c all represent distances. What is c the distance of? The center to the foci. So the center to a focus is c. If the foci are 150 miles apart, and it's centered at the origin, what is the distance from the center to one focus? 75, half of 150. Okay, that is your C value. Because C is the distance from the center to a focus. So therefore we know C is 75. Now we can use that C squared equals A squared plus B squared to find B. So let's see, we need 75 squared is 5,625 equals A squared, 40 squared is 1,600 plus B squared, and solve for B. So we would need 5,625 minus 1,600. So 4,025 is B squared. And actually, we don't have to go farther than this to actually find B, because B squared is what's in our formula. We can just substitute that in. So we have everything we need at this point to write our equation. I'm just going to write it right here. And then because h and k are both 0, I don't have to write x minus 0 and y minus 0. You can. You don't have to. I could just write x squared over a squared is 1,600 minus, it should have been a minus sign, not a plus, minus y squared over b squared is 4,025 equals 1. Now, if we would have drawn this in and used a vertical hyperbola, the x squared and the y squared would have been switched, but that would be an alternative answer that would also be correct. Your a and your b, a squared and b squared would still be the same. Okay, so questions on that one. I wanted to go through an example of me just giving you that problem. You might not have known what to do, but at least seeing how to use that information to get an equation. Any questions before we move on? All right, then example 3. So I'm going to go through with you how to get this equation into standard form first, and then I'm going to have you graph it. So you have a chance to practice graphing one of these, and I'll pass out the assignment. Getting a hyperbola equation into standard form is very similar to what we did with ellipses. So you want to get your variable terms, your like variable terms together. So kind of rearrange the equation so the y's are written together, the x's are written together, and get any constants to the other side. So I'm going to add 19 to both sides. And then I'm also going to switch around the minus 4x squared and the minus 54y. These are both minus. Just make sure when you're switching terms you keep the sign in front with it. So I'll have 9y squared minus 54y minus 4x squared plus 32x equals 19. And just like we did for circles and with ellipses, to get the equation into standard form, you have to complete the square. So I'm going to group the y's together and group the x's together. Before we complete the square, what do we have to do for the y's? Take a 9 out. There are a lot of side conversations going on right now, and they should stop, please. 1, you're not paying attention. 2, you may be preventing others around you from paying attention. 3, you're being disrespectful. So we have 9 factored out for the y's, so then y squared minus 54 divided by the 9 is 6y. I'm going to put a plus blank right away to complete the square. And then remember for hyperbolas, one of your variables, either the x's or the y's, that term should be negative or should be subtracted. Because there's a minus 4 in front of the x squared, that means the x is what's being subtracted. So I should be taking out the negative 4. So take out the negative with the 4 for the x's. So I have minus 4. And that means I have a positive x squared. I'm dividing 32x by a negative 4, so then I have minus 8x. Then a plus blank to complete the square equals 19. And then whatever I add on the left side, I have to also add on to the right. Okay, and then we complete the square. B divided by 2 squared. So for the y's, I have negative 6 divided by 2 is negative 3 squared is 9. So then what gets added to the other side? For the y's. 81. Make sure you multiply the 9 by the 9 in front. 81. And then for the x's, negative 8 divided by 2 is negative 4. Squared is 16. 16 should get multiplied by the negative 4. So that would be negative 64. And then we factor the trinomials that are on the left. So y squared minus 6y plus 9 will factor to what? Y minus 3 quantity squared, and then I still have the minus 4. X's will factor to be what? Minus 4 quantity squared, and then we have to add 19, 81, and negative 64. And that is 36. All right, we're not quite to our standard form yet. Hyperbolas have to be equal to 1. What do we do to get this equal to 1? Divide everything by 36. And then you should see the coefficients in front of the y and the x's will cancel. So I can, the 9 would become a 1, therefore that denominator would become 36 divided by 9, which is 4. The minus 4 would just be a minus 1. That denominator would be 9, and then the right side just becomes a 1. So the standard form is y minus 3 squared over 4 minus x minus 4 squared over 9 equals 1. So if you are asked just to write the equation into standard form, that is the process you would follow. Now that this is in standard form, I am going to have you graph it. I just want to make sure when you're graphing, you're using the correct HK, A, and B. So first of all, is this a horizontal or a vertical hyperbola? It's vertical. So make sure you're using vertical formulas if you're using the formulas. What is H? H is 4. K is 3. What is A? A is 2. So this 4 is the A squared. 9 is the B squared. So A is 2, B is 3. Okay, so go ahead and graph this hyperbola. I'll come around, check, answer questions. I'll also pass out the assignment, the remaining class time you have to work on either yesterday's assignment if you didn't do that, or today's. Make sure you are working on something.
Right.